Okay, today I will discuss about basic electronics, things to be covered, basic electronic circuit, Ohm's law, Kirchhoff law, and capacitors and inductors. And I think you have learned this in your digital electronic class last semester. So I will go very quickly, just revising back your understanding and knowledge on this topic lah. Okay. Okay, what is basic electronic circuits? You guys can can hear me clearly, right?
Yes.
Okay, what is basic electronic circuit? Okay, basic electronic circuit. So a circuit basically is a path for electrons to flow around. Okay, it's a circuit. It's a path for electrons to flow around in electronics. So in electronic, kalau kita panggil electronic circuit tu, it's basically dia macam litar. You have heard about F1 circuit kan? Dia macam F1 circuit lah. So basically it's a circuit for the electron to flow around. Okay, the path goes from the negative terminal of a power source through various components and onward to the positive terminal. So basically electron will move from negative to positive. So it's coming out from the source, power source, and then dia akan flow untuk cari positive terminal. Okay. Think of it as a circle. The path may split off here and there, but they always form a line from the negative to positive. Okay. So negatively charged electrons in a conductor are attracted to the positive sides of the power source. Okay. So that is the basic principle of how electron is moved in an electric circuit. So if you imagine your very simple here, the analogy that I'm showing you here is the electric circuit of your lamp, for example, in your room. So if you're using a battery, so you have a battery, you have the positive terminal and the negative terminal. So from the from the battery, the electron basically flow from negative to positive terminal. Okay, and your lights here or your lamp is actually become a load or resistor to the circuit. So whenever you have a component, electronic component inside your electronic circuit, it will become a resistor to the circuit. Okay. So if we translate that circuit into a circuit drawing, okay, these are the circuit drawing that is representing the lamp punya circuit. So here V representing the voltage coming out from the battery, and then you have the electrons going through the circuit through the lamp, which is representing as the resistor in the circuit. Okay, faham tak? So basically this is a very general basic knowledge about your about electronics. So usually in an electronic circuit we have a conductor. A conductor is a material, usually a metal such as copper, that allows electric current to pass easily. The current is made up of electrons. This is opposed to an insulator, which prevents the flow of electricity through it. So so basically the circuit too, how does the electron transfer from one point to another point is through a conductor. So a conductor usually kalau kita dalam bentuk wire, it will have an insulator outside it, and inside is the conductor. Okay. So insulator behave opposite the conductor. Insulator will prevent the flow of electricity, while the conductor is the function is to allow the electrons to move inside the circuit. Okay, so it will move from negative to positive terminal. Okay, these are the three main parameters that you need to understand in electronics, basic electronics, which is the voltage, current, and resistance. So voltage is the electrical force or pressure that causes current to flow in a circuit. So if you imagine a tube, okay, piston. So it's basically the voltage is basically the piston that push the fluid to go through the tube. So that is voltage if you imagine it. Kalau you pernah ambil ubat guna apa tu picagari kan. So the piston of the picagari is actually the voltage. So voltage is the force, electrical force, yeah, yang pressure the current to flow. Okay, so voltage will be the force that is pushing the water, okay, forward. So this is the analogy, and it is measured in volts, V-O-L-T, volts. Yeah. Okay, how do we measure voltage? We measure voltage between 2 points or across a component in a circuit. So when measuring a DC voltage, DC means direct current voltage, we have to make sure the polarity of the meter. Okay, so if we have a meter, usually we must have the voltmeter must have the polarity, positive and negative. So we have to make sure that the positive terminal will be connected to the positive of the battery, and then the negative terminal is connected to the negative terminal of the battery. Then you will get the measurement of the voltage across the component in the circuit. Okay, current on the other hand is the movement of the electrical charge, which is the flow of electrons through the electronic circuit. So if you imagine in the analogy here, current will be the flow of water moving through the tube. Okay, so the water or the fluid moving through the tube is the current, and the unit is amperes. Okay, current direction is from positive to negative voltage. So current is opposite of the electron. Okay, electron move from negative to positive, and so the direction of current is from positive to negative. Okay. So uniform flow of electron through a circuit is called current. Okay. So how do we measure current? So we measure current using an ammeter lah, ataupun ammeter. Okay, using ammeter to measure current, we must break the circuit, meaning we need to measure it in series with the component inside the circuit. So if you want to measure what is the current, because current they flow in the circuit, so you need to measure the current in series of the circuit. Okay, so to measure current, you must break circuit and install meter in line. Okay, measurement is imperfect because of voltage drop created by the meter. So the meter itself, when it goes inside the circuit, it will become the resistor, a resistor to the circuit itself. Okay, so there will be some measurement error when you, very small measurement error depending on the type of ammeter that you're using. Okay. Okay, resistance is anything that causes an opposition to the flow of electricity in current. So basically resistance is whatever that slow down the movement of the current inside the electronic circuit. It is used to control the amount of voltage and amperage in the circuit. Everything in the circuit causes a resistance, even wire. Okay, so if you put in a circuit, so just like what I said just now, if you put the lamp become a resistor. If you put your ammeter to measure the current flow, is also become the resistance to the circuit, and even the wire itself have some resistance in it. Okay, and the unit for resistor is ohm. Alright, next, this is okay, resistor macam mana rupa resistor. If you, these are the symbols that usually used in electronics, macam ni lah, resistor. And these are the components. I think you have seen this and you have used it in your basic electronic class last semester. So all materials have a resistance that is dependent on cross-sectional area, material type, and temperature. So all materials, it has different resistance. Okay, it depends on the cross-sectional area, material type, and also the environmental temperature. So if at different environmental temperature, the resistance will be different. So a resistor dissipate power in the form of heat. So a resistor ni dia akan membuang power, okay, in the form of heat. So usually if you have some heats coming from your electronics, that means there is resistance there. Okay. Okay, there are various type of resistors. The one that I show you in the previous slide is the most basic resistors, and it's this one. This is very regular one, the most common one, and it based on the color of the strip on the resistor. So if the color is different, you have different combination of color, you will have a different value of ohm inside the resistor. So the symbol, usually we use this kind of symbol, and there is also a lot of other resistors that are also resistor that we can change the value of the resistor. So for example, potentiometer like this, you can adjust the potentiometer so that it will give you a different resistance value. Okay, so usually for resistor that can be adjusted, the symbol will be something like this, you know, with an arrow showing that the value of the resistor can be changed. Okay, and it's also called variable resistor. Okay, do you have any questions so far? Semua okay ke?
Okay, Doktor.
Okay.
This is just macam ni kan, recap sahaja your understanding on electronics. So when we want to measure resistor, okay, so how do you measure resistor? So if your resistor is in the circuit like this, kan, macam contoh tadi you ada battery and then you connect it to the lamp. Lamp to become your resistor, and you want to know how much resistance at the lamp. So you take your ammeter and you put your ammeter here like this, and this will not work. Okay. Okay. So for you to measure the resistor, you have to take out the resistor, kan? Macam take out the lamp tadi tu and put your ammeter, positive terminal and negative terminal, dekat dekat resistor tu. Then you will get the right value. Okay. Okay, how do we calculate resistor? There are two ways for us to calculate the resistor. If the resistors is in parallel, okay, so the overall resistance is obtained by taking the sum of the reciprocals of individual's value. That means 1 over R, total R, is equal to 1 over R1 plus 1 over R2 plus 1 over until Rn, until how many resistance you have in the circuit. Okay, that is when the resistor is in parallel. When the resistors is in series like this, dalam satu line macam ni, okay, so how do you measure the R? The total R between point A and point B. So if you want to, yeah, just simply add all the resistor R1 plus R2 plus R3. That is the total resistor between point A and point B. In this case, the total resistor will become berapa?
9.
9 kilo ohm. So remember, when you make a measurements, you have to make sure that you do not miss the units. Okay, kilo or, and also the unit of it. For example, in this case resistor, you have to put it, if it's resistor then it is in ohm. Make sure that is very important in measurements. Okay, so that is parallel resistor. Okay, we also has Ohm's law. Okay, what does Ohm's law says? Ohm's law is used in electronics to calculate the relationship between current, voltage, and resistance. So there is a relationship between voltage, current, and resistance. So as we recall back, current is the force that make the, voltage is the force that make current flow. Okay, and current is the electrons that flow in a circuit. Resistance is anything that make the that slow down the flow of the current. That is resistance, that prevent the current flow. Okay, that is resistance. So you have to remember what is the definition of the current, voltage, and resistance, and how do we represent the relationship between current, voltage, and resistance is through Ohm's law, which is V, voltage, is equal to I multiplied by R. Okay, So if you move around the parameters, I will be equal to V over R, or R is equal to V over I. Okay. So please be fluent with this relationship between voltage, current, and resistance. Okay, so for example, if we knew the battery was supplying 12 volt and the current being generated was 12 ampere, then the resistance would be what? So we know the V is equal to 12, and we know the I is equal to 12 as well. So R will be V over I. That means 12 divided by 12. And you will get the R is equal to 1 ohm. Okay, that is very straightforward. There is another theory that we can use to describe the behavior of current and voltage in a circuit. So we use Kirchhoff law. So what does Kirchhoff law say? At any point in a circuit, the current flowing in equals, sorry, at any point in a circuit, the current flowing is in equal to the current flowing out. Okay, the current flowing in equals to current flowing out. So total current in masuk is equal to total current keluar. For example, you have this point. Okay, so that means in this case, what are the Kirchhoff law equation for this gambar ni? So it should be I3 plus I2 is equal to I1 plus I4, right? Everybody agree?
Yes.
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 And because of that, because the total current in and is equal to the total current out, so if you sum up all the current, you sum I1 plus I2 plus I3 plus I4, the total should be zero lah kan, sebab it cancel out each other, betul tak? Okay, sorry. And then there's another one. What does the Kirchhoff law says about voltage? Okay, the directed sum of the electrical potential differences around any closed circuit must be zero. That means in one closed circuit like this, the total voltage across the circuit should be zero, meaning V1 plus V2 plus V3 plus V4 should be zero. Okay, so that is what Kirchhoff law said about a circuit, about current and voltage in a circuit. Okay, now we shall discuss about DC circuit analysis. DC is direct current. Okay, direct current circuit analysis. We have two type of current flowing in a circuit: alternating current and direct current. So let's discuss about the direct current first. So when the voltage source is the battery ataupun direct current, okay. So the circuit analysis will use the direct circuit analysis direct current circuit analysis. Okay, so basically we use Kirchhoff law and Ohm's law, just like what we discussed before. For example, in this case, we know that the voltage between B and C, okay, kita boleh measure what is the voltage between B and C. Okay, so it's supposed to be the voltage between B and C is the current yang lalu dekat sini. So current yang lalu dekat sini, dekat circuit ni, semua sama I which is I times resistance which is R2. Okay, ini faham tak? Do you understand how do we get the voltage across B and C? Boleh ke? Faham ke? Perlu ke saya tunjuk dekat lightboard? Faham kan? Straightforward kan yang ni? So kita kena tahu what is I dulu. Okay, I dekat sini, IAC, I antara A dengan C sama juga dengan I antara B dengan C. Because current dalam satu circuit yang tertutup, dia sama je. Okay, so IAC is equal to IBC. So IAC is, macam kita nak cari I. Mengikut Ohm's law, I is equal to V over R. So V antara A dengan C is V lah ni, V. Okay. And then total R dalam circuit ni ikut series ke parallel ni?
Parallel.
Siapa jawab parallel? This is actually series. That's why total R is R1 plus R2, kan? Sebab if you, okay, just forget A, B, C ni. A, B, C ni cuma they just want to label. The point here is A. The point here is B. The point here is C. If this is not there, you actually only have V and then you have the circuit with R1 and then R2. Betul tak? Sorry.
Betul.
So it's a
Okay,
very
faham.
it's a very simple circuit. It's only have two R, R1 and R2. It's in series. So the total R is R1 plus R2. So untuk dapatkan I, you have to divide V over R. So IAC is equal to VAC over total R, R1 plus R2. So you dapat IBC lah juga, okay? IBC is equal to IAC. So VBC, sekarang kita nak tahu what is V across B and C. So untuk dapatkan V across B and C, you need to use the Ohm's law. V is equal to IR. So I tadi kita dapat IBC, which is equal to IAC. And then R across B and C is R2, right? So you multiply IBC. IBC is VAC over R1 plus R2. VAC over R1 plus R2 multiplied by R2, okay? So to see whether you understand or not, okay, for example, suppose you are trying to measure the output voltage of a source. What is the voltage drop from A to B in this case? Okay, cuba buat yang ni dulu. I give you, do you want to go into a breakout room ke? Macam mana buat sama-sama dengan kawan, and then I will call one group to explain. Nak breakout room ke tak payah?
Tak payah. Tak payah, doktor.
Alright, so why don't I give you 3 minutes for this one? Kalau ada sesiapa yang dah siap dan nak bagi tahu macam mana jawapan dia, boleh beritahu saya. Okay, siapa dapat jawapan? Apa jawapan dia? Anyone? Dapat tak jawapan? So circuit tu, if you draw back, so the circuit will be nampak tak?
Nampak.
Nampak.
Okay, setuju tak yang circuit tu kalau saya draw balik, dia sama juga dengan circuit yang kita lukis sebelum ni. Kan?
Setuju.
So if you see at the ni, dia punya, kalau kamu tengok dekat sini kan, dia punya sini adalah negative terminal ataupun ground. Yang kalau tanda macam ni maksudnya dia ground. If both are ground, meaning you can connect it together. So here is ground. Okay, and then you have RS, you have voltage, connect to RS, and this is A, and this is B point, right? So soalan, sorry, bukan kat situ kan? Betul ke ni A dengan B? A dekat this is A, this is B kan? Meaning A and B is the point across our meter. Okay? So soalan dia, what is V
Drop.
antara voltage drop antara A and B is equal to apa jawapannya? Yang you dapat? Siapa nak bagi tahu jawapan? Anybody? Semua tak berani bagi jawapan ke? So sepatutnya you should get the answer macam tu. Siapa dapat macam ni? Sama. So basically VAB is equal to I multiplied I kan? V is equal to I multiplied by apa? Ohm's law. IR kan? Okay, I itu adalah all the current flow through this circuit is I. Okay? So R meter lah kan? VAB is equal to VAB is equal to I kali dengan R meter. So what is I? I is V over
R.
voltage source over total R. Total R is what? RS plus
Rm.
R meter. Okay. So kali dengan R meter. So you should get that lah. Boleh? Ada soalan?
Ada, faham.
So maksudnya this is to show you that if we in this case kita tunjuk dia dalam bentuk apa tu? Dalam bentuk simbol resistor. Sebenarnya ammeter ni maksudnya adalah kita letak ammeter, kita punya ammeter dekat dalam circuit tu because we want to measure the voltage kat situ. We put the meter. Okay, so the meter actually, the ammeter actually has its own resistance. And the voltage will depends on the voltage across that point will depends on the resistance inside the meter. Okay. Okay, let me turn off this one. Okay, let's do another exercise. Now suppose you make the same measurement using an oscilloscope as a meter. Okay, now you're using an oscilloscope as a meter. The total AB resistance is, okay, total resistance antara point A and point B is 1 meter ohm. Sorry, 1 meter ohm. Mana ada 1 meter ohm? 1 mega ohm. Okay. So the total AB resistance is 0.5 mega ohm. Sorry, AB, sorry. Okay, the total resistance is 0.5 mega ohm ya, tapi the resistance between A and B point is 1 mega ohm and you have another oscilloscope meter dekat sini. Okay, so the total R dekat sini adalah 0.5 mega ohm. Okay, so the voltage drop from A to B will be macam ni lah, you boleh kira macam tadi yang kita buat. Okay, V is equal to voltage bahagi total R plus multiplied by R across total R across A and B. So the question is, what is R meter? Apakah value R meter kat sini? Siapa boleh quickly calculate and let me know the answer? So if you remember the apa tu Ohm's law and also the theory about the R, how to calculate R, you should be able to answer this question. Okay, siapa boleh jawab yang ni? Anybody? Saya panggil nama boleh? Ivan ada Ivan?
Ada.
Ivan, have you calculate what is R meter?
Belum lagi.
Alright, okay, I'll give you another 2 minutes, everyone, 2 minutes. Calculate. Okay, siapa yang dah dapat jawapan, could you write down your answer inside the chat box? Anyone? Tak ada siapa yang lagi yang dapat jawapan? So what equation do you need to use for this one to get the R meter value? Negative 0.3 ohm. Who else? Mustaqim dapat negative 0.3. Anybody else dapat jawapan macam tu? Which equation do you use? Okay, I give you a clue. You need to use this equation. 1 mega ohm, Faris. You need to use this equation. Parallel resistor. Because the meter is parallelly installed inside the circuit. So you need to use this. Okay, so the answer is, so how do you calculate? Using the parallel resistance equation. So 1 over R total, R total tu, one over REB, sorry, R total, R total at AB is equal to 1 over apa? 1 mega ohm plus 1 over R.
R meter.
Meter.
So using this equation, okay, what is R total AB? Dia dah beritahu kan in the questions. What is the R total AB?
0.5
Yes,
mega ohms.
0.5 mega. Remember the units are very important. So based on this equation, you just rearrange to get this R meter ni. Kan? So how do you rearrange? So 1 over R meter is equal to 1 over 0.5 mega ohm minus 1 over 1 mega ohm kan? Betul tak?
Betul.
So yang ni you boleh solve dah. Okay?
Betul.
So this one is equal to 2 micro ohm minus 1 micro ohm is equal to 1 over R meter. Okay? So R meter, nampak ke ni? Tak berapa nampak. R meter is equal to 1 micro ohm. Sorry. R meter is equal to 1 over 1 micro ohm is equal to 1 mega ohm. So siapa jawab tadi yang dalam chat box tu? So Faris Suleiman, you are correct. The answer is 1 mega ohm. Okay. Semua nampak tak? Semua agree with my nampak tak?
Agree.
Nampak.
Alright, we can move to the next slide. The next slide is about, okay, now we are going to alternating current. So alternating current, so tadi yang kita buat tadi, calculation tadi is simply direct current tau, DC. Okay, direct current. So now we also have alternating current circuit. Okay, alternating current circuit. So bila alternating current means the power supply yang provide the current tu is alternate atau AC punya source. Okay, many electronic signals encountered in physical measurement vary rapidly with time. The circuit used to record these signals are similar to those we have just encountered, but their analysis are somewhat more complicated. They are analyzed as AC circuit rather than DC circuits. In general, 3 quantities are necessary to specify an AC signal. Okay, one is amplitude. These are the 3 main parameters that you need to be familiarized when you do an AC circuit analysis. Amplitude, frequency, and phase. So what is amplitude? Amplitude is how big the signal is in unit volts. While frequency is how quickly the signal changes. Okay, so amplitude, frequency, and phase. Phase a starting point for the signal in the unit of radians. So boleh faham tak apa tu frekuensi? Okay, yang ni pun penting juga ni. you have heard about frequency a lot of time, but do you know exactly what is frequency means? Okay. So frequency is how quickly the signal change. Okay, let's talk about amplitude first. So if I draw a signal, okay, a circuit usually an AC punya signal dia dalam bentuk apa? Sinusoidal macam ni. Okay. So amplitude adalah berapa besar signal tu. So kalau signal tu dalam voltage, so amplitude is how big. So meaning from here to here. Is how big. This is amplitude. Faham? Kalau frequency pula, you want to know how frequent the signal dalam masa satu saat. Okay. Contoh kalau kat sini, ni adalah 1 saat. Okay. So dalam kes ni, dalam masa 1 saat, berapa frekuensi dia? 1 lah kan? 1 Hz lah, sebab dalam 1 saat dia hanya ada 1 complete circle. Nampak tak? 1 circle. So kalau
Faham.
2 Hz, what does it mean? Kalau 2 Hz dalam masa 1 saat, you have 2 complete circle. 1, 2. Okay? So ni 2 Hz. Okay? Nampak kan? 2 Hz. Okay, kalau 3 Hz,
3
Tambah satu cycle lagi.
ada 3 cycle dalam 1 saat. Kalau 50 Hz, ada 50 cycle dalam masa 1 saat. Kalau 500 Hz, you have 500 cycle in 1 second. Meaning to say the signals are very fast if the number of frequency is very high. Faham tak? Kita nak tahu dalam masa 1 saat tu berapa signal yang complete boleh lalu. Okay, that's why when you punya processor kan, you punya computer or you punya handphone punya processor, if the frequency is very high, contoh macam berapa mega kan, berapa megahertz, that means it's very fast lah. Okay, laju, sangat laju. Okay, yang ni yang kita boleh lukis, you can draw it like this so that you can see. But usually if the system has electronic system has a very high frequency, so the frequency will looks like macam mana? Macam ni kan. Sebab dalam masa 1 saat tu ada beratus-ratus cycle. So that means the frequency is very fast. Faham?
Faham.
Right. So kalau a phase, what is phase? Phase is a starting point for the signal in unit radians. So kalau phase pula, contoh saya lukis yang 1 Hz je lah, yang 1 Hz senang. Sebab you nampak satu signal complete kan, macam ni 1 Hz. So phase adalah from one peak to another peak. So if you have another peak down here, okay, sini ke sini. So ke sini is one phase. Okay, so it's also the same if I draw it from here to here. This is a phase lah, satu fasa. The phase of the signal, the starting point for the signal. Okay, dalam unit radian. Okay, so that is things that you need to understand about the circuit, the AC and alternating current circuit analysis. If the only circuit element are resistors, there's no formal difference between the analysis of AC and DC circuit. So maksudnya kalau circuit tu sama macam DC circuit juga, dia ada source, dia hanya ada resistor. So that is very simple, straightforward. The analysis sama macam tadi, kita boleh guna Ohm's law, V equal to IR. Tapi when there is another element inside the circuit, which is we're going to discuss after this, the amplitude of the AC signal behave exactly the same way as DC voltage, and the frequency and phase remain unchanged. Okay. However, if there is other component inside the circuit like capacitors or inductors, okay, there is a special theory that we need to apply in response to the signal. Because the circuit now respond differently when you have capacitor and inductor. Okay, before we go into the analysis of the AC circuit, we need to be familiarized with the components of AC circuit. Usually in AC circuit, you will have capacitance. Okay, what is capacitance? Okay, capacitance is how the capacity of the capacitor to store charges. How much charge inside the electric field. Okay, so a capacitor is used to store charges. The unit is Q. Okay. Oh no, the symbol for capacitance, the symbol for charge is Q. So Q is equal to C multiplied by V, which is capacitance multiplied by voltage. Okay, so Q, the unit for Q or charge is coulomb, and capacitance, the unit is farad. So in the energy equation, so energy is equal to half capacitance multiplied by voltage square, okay, in the unit of joules. Okay, so if voltage is constant, no current flows. If voltage changes with time, then you will get the current flow inside the circuit is equal to C dV dt. Okay, so what does it mean here? If the voltage across the circuit kat sini, kalau tak ada voltage, zero, so tak ada current flow, so capacitor tak akan charge. Okay, so capacitor punya charge dekat dalam capacitor ni will be zero. Tapi once you start to provide voltage into the circuit, the capacitor start charging and the current flow inside the capacitor ni akan meningkat sehingga maksimum. Okay, we'll discuss about this I think in the next lecture kot, we'll discuss about this later. Okay, so the unit for capacitor is okay, capacitance is the unit is farad. Okay, the symbol is like this lah, dia macam dua parallel macam ni. Usually we use this one. Okay, characteristic equation of capacitor, this one. I is equal to C dV dt and V is equal I over C I dt. Okay, so these are the example of capacitance that usually being used in the circuit. Okay, usually yang biasa kita nampak macam ni lah. This one, this one. Okay. Alright, we also have inductance, another component that is very important in electronic circuit. In AC punya circuit is inductance. So an inductor is a multi-turn coil or a small diameter wire. So kalau ada diameter wire yang turn macam ni, buat gelung macam ni, so it become an inductor inside a circuit. So the symbol is L and the unit is Henry. The energy stored in the inductor is equal to 1/2 multiplied by the L and multiplied by I, the current, to the power of 2. So if current changes with time, okay, bila current start flowing inside the circuit, then voltage is equal to L di dt. Okay, so inductor sama juga, capacitance pun store energy. Okay, tadi capacitance also store energy tapi dalam bentuk charge. Okay, tapi kalau inductor it stores energy in a magnetic field. Yang tadi dia store energy in electrical field. So this one it stores energy in a magnetic field. So sebab bila you make a coil like this, turn like this, it will become a magnetic field and it will store energy. Okay, that is inductance. The symbol for inductor sama lah, bentuk dia macam seperti its physical appearance where dia ada turn coil macam ni. Okay, so this is the one that we usually use. And this is the characteristic equation for inductance, V equal to L di dt. Okay. Okay, so that's basically the first lecture of today. Ada soalan tak sebelum saya go for the next lecture? Ada soalan? I will share with you the next lecture.
Ada ni.
Sekejap. Next lecture will be okay, we continue on the, because just now we already discussed about the AC circuit. So AC circuit usually it has RC, which is resistance and capacitance. So basically this is all theories. Maybe later you can look at the slides and go further studies on it. I will give you a few macam exercise for you to try on. Okay, so this is the characteristic of RC circuit. So RC circuit ni macam mana? So it has a voltage, and then you have capacitor inside the circuit. So it become and then it also has resistor. So it become a RC circuit. So capacitor stores energy between a pair of plates. When voltage is applied to the capacitor, the charge builds up in the capacitor and the current drops off to zero. So maksudnya, mula bila kita supply voltage, current akan lalu kat sini kan? Current akan lalu through the circuits, and when it start to pass through the capacitor ni start to build up charge kat sini. So the charge tu akan menaik dan the current tadi bila dia lalu sini dia akan drop. Every time dia lalu dia akan drop sampailah I ni akan jadi zero dan the current the capacitor ni akan, the voltage akan goes up to paling maximum lah. Okay, so let's see how the equation to represent this okay, there are two type of voltage that can be applied in the RC circuit. One is the constant voltage. Contohnya ni voltage constant tau, DC. Maksudnya ni DC current, DC voltage kita bagi. So if we give DC voltage inside the circuit, okay, so these are the equations. Sama juga, this still guna Ohm's law. V is equal to IR ataupun RI. Samalah, V equal to RI. So V across the R kat sini is equal to R kali dengan I, which is I, current yang melalui circuit ni. Okay, voltage across the capacitance pula is equal to 1 over C integrated by I dt. Okay, that is the equation for the voltage across the capacitor. And Kirchhoff law will say that Ri plus, meaning VR plus VC is equal to V. Okay, VR plus VC is equal to V. Okay, so this is VR, this is VC. So it's equal to V. So okay. So when you do a differential equation, if you learn from your mathematics 2, differential equation, you will get this. Solving this integration punya equation using differential equation, you differentiatekan this one. Differentiatekan this equation, you akan dapat R di dt plus I over C equal to 0. From this, we can solve what is I. Okay, so from this, we solve it. I is equal to V over R, E to the power of T. Okay, so bila kita dapat equation I ni, sebab apa kita nak tahu berapa I ni? Sebab kita nak tahu how the I is behave. Kita nak tahu macam mana current ni behave bila dia jumpa capacitor dalam circuit ni. Okay, so kalau kita tengok equation I ni, bila ada capacitor, I ni is equal to V over R multiplied by exponential T over RC. So it's an exponential punya equation kan? Exponential equation ada negatif. Apa maksud dia? Maksud dia I tu akan berkurang. Daripada mula-mula dia disupply pada circuit tu, mula I tu very high, besar, banyak kan? Tapi throughout the time, bila capacitor tu charges, I ni akan berkurang sampailah dia jadi zero. Okay, faham tak? So this is what it means by a circuit that has capacitor inside it. This is how the current behave. So dia akan exponential decay. So what about the V? What about the VC? VC is the voltage dekat kapasitor kan? So voltage dekat kapasitor pula akan meningkat macam ni, exponentially increase. Meaning apa maksudnya bila voltage dekat kapasitor exponentially meningkat macam ni? Siapa tahu? Maksudnya kapasitor tu dia charging lah. So the charge inside the capacitor semakin banyak. Yes. So while the voltage over the resistors drop, the voltage over the capacitor rises as it is charges. Okay. So that is what it means by this equation. Okay. It want to show you how the current flow and the voltage across the capacitor behave when you start flowing the current inside a circuit that has a capacitor. Faham? Siapa yang tak faham?
Faham.
Okay. Okay, so we also have another case when we have just now tadi tu kita ada case when we have a constant voltage applied to the circuit, but when we have a variable voltage supply into the circuit, so the equation will be slightly different. Okay, so we have to substitute I is equal to dq dt. Okay, so I ni adalah perbezaan antara charge tu berbanding masa. So as the charges develop across time, that's how I is behave. Okay, so the equation bila dah buat equation, basically guna differential equation yang belajar dalam matematik 2, you will get this equation. Okay, Ri plus O1 over C ni sama tadi. Ri V tu VR plus VC is equal to V sama. Tapi now you have to substitute I with dq dt kan? This one. So when you substitute di with dq dt, you akan dapat R dq dt plus 1 over C Q equal to V. Okay, ni bila you differentiatekan using the differential equation lah. So this is the equation when you use a variable voltage inside the circuit that has capacitor. Okay. Okay, this is an example. Siapa boleh buat yang ni? Okay, this is one example that you can try. Boleh tak? Try buat ni dulu. I give you 5 minutes. And if you want to discuss with your friends, you also can discuss. Try to use the equations that I've shared with you in the previous slide. Okay. So dia ada a series of RC circuit with R equal to 5 watt. Sorry, ni 5 ohm R equal to 5 ohm and C equal to 0.02 farad. Connected with a battery E equal to 100 volt. So kalau battery tu equal to 100 volt, is it variable voltage ke dia constant voltage?
Constant.
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 Good. So it's constant. Okay. So you should use the equation yang first kali I showed you, and then at T is equal to 0, the voltage across the capacitor is 0. Betul lah kan? Bila masa T 0, maksudnya T ni 0, maksudnya T masa yang belum mula lagi, belum on lagi. Okay, mestilah capacitor 0. So the question is, obtain the subsequent voltage across the capacitor. Maksudnya dia suruh kamu cari what is VC. So if you look back at the equation of VC untuk constant voltage, kan ni constant voltage. So the equation for VC adalah this one. Okay, so try to get this equation. Okay. And then B ditanya as T go to infinity, find the charge in the capacitor. Okay. So what is the charge in the capacitor? So charge punya equation, you can use two type of charge punya equation. Kalau kamu pergi, alamak tak ada kat sini. Sorry. You can use charge punya equation which is Q is equal to C multiplied by VC. Kan? Okay, try buat dulu. You all buat dulu. I'll excuse myself sekejap sebab hujan lebat ni kat rumah saya nak pergi angkat baju.
Boleh.
Okey doktor, boleh.
What is this?
Okay, semua boleh dapat jawapan dah? What is your answer for BC dulu? Anybody? What is the voltage across the capacitor? Dapat tak? Voltage across capacitor. So, tunjuk kat kamu BC. Nampak kan? BC is equal V multiplied by 1 minus E to the power of negative T over RC kan? Ni equation dia. So this one, 1 over RC is equal to what? Okay, so 1 over RC is equal to 1 over 5 multiplied by 0.5 multiplied by 0.02. R is 5, C is 0.02, so you will get 10. Betul? So the equation for BC is becoming BC is equal to V100 multiplied by 1 minus E to the power of negative 10T. Okay? So dah siapa dapat sama macam saya ni? BC. BC is 100 multiplied by 1 minus E to the power of
T.
10T. Okay? So what about Q? Sekarang ni kita nak kira berapakah charge. QT is equal to C multiplied by CB. Okay? So kalau you buat C adalah 0.02 kali dengan CB tadi kita dapat 100 minus 100 E to the power of negative 10T kan? So if you solve this equation by substituting T ni, dia kata T at infinity kan?
Zero.
Infinity lah bukan zero. So,
Infinity.
so ini example 2. Okay yang ni. ST menghampiri infinity. So maksudnya T ni infinity. Kat sini. So jadi apa? E to the power of infinity jadi apa? Kosong lah kan? E to the power of infinity you will get 0.
Kosong.
So bila 0 maksudnya 0.02 you multiply by 100 you akan dapat 2. Apa unit charge? Coulomb. C-O-L-O-U-M-B. Okay? So this is your B. Okay, yang untuk A tu, untuk jawapan untuk A, what is the, obtain the subsequent voltage across the capacitor. Subsequent voltage across capacitor maksudnya VC lah. voltage across capacitor, VC. So VC is equal to 100 multiplied by 1 minus e to the power of 10 t. And then you can calculate the charge where C multiplied by CV by substituting the T is equal to infinity. So you akan dapat dua column. Okay. I have another example here. Example 2, but I think I will leave you guys to try it later lah by your own. Okay, and then I can share with you the answer later. Probably I can send you the solution for example 2 and 3. I think I have another. Yeah, 2 and 3. I have 2 and 3 example. Okay. Alright, so that's basically what I want to cover in this today class. Ada soalan, apa-apa soalan tak?
Tak ada, doktor.
Faham tak apa yang saya cuba terangkan in this?
Faham.
Okay, apa yang kau faham? Sekejap, kita apa ni? Kita buat formative assessment sikit with all of you. So what do you guys understand about what we lecture today, the class today? Saya nak cakap dulu. Let's talk about our first part of our lecture. Cuba recap balik apa yang kita belajar on the first part of our lecture.
Ohm's law.
Okay,
Kirchhoff law.
Ohm's law is to explain the relationship between what?
Voltage,
E.
current,
IR.
IR.
Okay, voltage, current and resistance.
Resistance.
Ohm's law. Okay, and then you also have Kirchhoff law. What is Kirchhoff law?
V in sama dengan V out.
Current flowing in equal to current flowing out.
Elok lalu.
I in sama dengan I out. What about V? V total voltage is equal to
Zero.
Zero.
Remember that one, okay? Total voltage is equal to 0. But before we discuss about Ohm's law and Kirchhoff law, we discuss a little bit about what? The definition of the voltage, current and resistance. Okay? So you have to understand what is voltage. Apa itu voltage?
IR.
Electrical.
Force, okay? Remember, keyword dia force. Okay? Voltage adalah force yang menolak elektron untuk melalui dalam satu circuit kan. Okay, and then what is current?
Movement
Movement of
electrical.
electric charge.
Electric.
Okay, ya ke? Betul ke tu definition dia? Current.
The flow.
Betul.
The flow of charge kan, electrons. Okay, and then you have resistance. What is resistance? Resistance ni anything that prevent the current to flow inside the electronic circuit. Okay, anything that prevent, so it will become a resistor. Okay, so that is clear. So you have to be very clear about what those means, and then we discuss about Ohm's law, Kirchhoff law, and how do we calculate them inside the circuit. Okay, and then we also discuss when the circuit have resistance and capacitors, right? So when the circuit has resistance and capacitors, so there is a RC circuit analysis. Betul tak?
Yes.
Okay, so this is the RC circuit analysis. We have go through how do we calculate the RC. So apa yang berlaku kat dalam circuit yang kita ada constant voltage, kita bagi constant voltage, lepas tu dia ada capacitor. Apa yang berlaku?
Voltage tu akan menurun.
Voltage across capacitor akan jadi
Bukan V.
voltage across capacitor mestilah meningkat sebab capacitor dia charging.
Betul.
So yang ni kena faham. You have to understand the concept. Okay. So voltage across capacitor akan meningkat. Tapi voltage yang across resistor yang akan
Menurun.
Okay, current pun, what about current? Current yang melalui circuit.
Current. Ya, menurun.
Current menurun. Okay. Yang meningkat hanya yang dekat kapasitor je meningkat. Sebab kapasitor je yang charging. Seolah-olah dia dah absorb all the energy from other component dekat dia. That's why
Yeah.
just like Kirchhoff law tell kan, total voltage adalah zero. So bila voltage dekat kapasitor meningkat, mestilah voltage dekat resistor akan menurun sebab total voltage must be zero.
Zero.
Kan? They cancel out each other. Okay? So that has to be understood. Okay, and then kita ada variable voltage. Okay, tadi tu direct voltage. So bila variable voltage, the equation will be slightly different. Tapi sebenarnya dia punya konsep adalah sama je. Okay, cuma you want to calculate the charge tu, the equation tu jadi slightly different. Okay. Okay, what else do we learn?
Example.
Okay, lepas tu kita buat example kan. Okay, that's it. So basically that's what we discussed today. Next week we'll continue a little bit more on AC circuit analysis, alternating current circuit analysis. Okay. And then kita buat exercise lah minggu depan. Kita buat a few exercise. Okay, for you quickly. Lepas tu the next one we will discuss about signal conditioning. Okay, so basically once you're familiar with this basic electronic, then it will be easier for you to move forward to the next topic, which is signal conditioning. Remember in instrumentation system kita ada memula power supply kan? Lepas kita ada power supply, and then we have apa lepas power supply? Transducer. Okay, lepas transducer kita ada signal conditioner. So next topic we'll discuss about signal conditioner, how signal conditioning circuit will be used to adjust the signal that we measure from instrumentation system. Okay?
Yeah.
Okay.
So do you guys have any question before we dismiss? Semua dah tanda tangan kehadiran?
Udah.
Okay, so with that, I think that will be the end of the class. If you don't have any questions, okay, yeah?
No.
Okay, all right.
Okay.
Thank you so much. I'll see you again next week, inshallah.
Okay, thank you, Doctor.
Thank you, Doctor.
Oh.
Yeah, Doctor.